Knecht micro-tunneling equipment is perfectly suited for rock and mixed soil conditions under groundwater. The pipe jacking job site consists of the onshore shaft, the jacking frame, pumping systems for slurry material removal, separation plant, pipe stock, and an operating container from which the machine is controlled. This onshore shaft was constructed with sheet piles. It is approximately 8 meters deep with an inclination of 8 degrees. The rotating cutting wheel excavates the material at the tunnel face. Rock and stones are crushed by the discs of the cutting wheel and then ground down to the appropriate grain size in the cone crusher situated behind the cutting wheel. The material is picked up in the slurry circuit and transported to the separation plant through the slurry discharge line. This line passes through the machine and the jacked pipes up to the surface. In the separation plant, the excavated material is separated from the water. The machine and the pipeline advance continuously with the help of the jacking frame and intermediate jacking stations. The movable cutting head of the machine is controllable and thus enables the jacking of curved pipelines. So the rocky coast and reef can be undercrossed before the pipeline is jacked horizontally to the arrival point. To keep the jacking forces of the jacking frame as low as possible, the so-called intermediate jacking stations are used during this long-distance pipe jacking. Every intermediate jacking station only jacks a section of the pipeline, so the required jacking forces can be kept at a low level. With this method, it is possible to realize long-distance pipe jacking. The reception pit is located 25 meters below the water surface. A barge is positioned above the arrival point of the machine and is kept in its position by mooring lines and a ship. At the arrival point, a reception pit of approximately 20 meters length is excavated. A crane loads the excavated material onto a ship docked to the barge. A part of the soil covering the machine is excavated, the rest sucked away by a scuba diver and separated in a settlement tank on the barge. The machine is hermetically sealed and kept under overpressure, thus preventing seawater from entering the machine during the recovery. The pipeline is flooded with water from the onshore shaft. A diver assembles a crossbeam to the machine. Four hydraulic cylinders are installed in the rear part of the machine. To separate the machine from the first product pipe, the hydraulic cylinders are extended. The recovery itself can begin. The complete machine is lifted by the crane and put on a frame on the barge, which returns the tunneling machine to the harbour. The diffuser itself consists of prefabricated reinforced concrete units. These are lowered into the reception pit and connected to the pipeline. Afterwards, the pit is filled up. A depth of approximately 25 meters below the water surface is sufficient. The pollutants are rapidly washed away by the currents near the sea bottom. A large quantity of seawater is available to dilute the concentration of the sewage plume before it reaches the surface or deposits at the sea bottom. If the wastewater is discharged at a sufficient distance from the coast using sea outfalls, the danger of serious pollution is